Okay, so I'm making this video to help y'all fill in this flow chart and kind of help us get a handle on stoichiometry and how to go from one thing to another with a little bit more ease and a little less prompting. So I handed these out last week, I believe. So find yours. I handed out when I did the ideal gas law handout. So find yours and let's walk through filling it in. And this is just going to be kind of a diagram for how you're going to set up your problems. Okay, so the middle big circles, this is going to be moles of compound A, and this would be moles of compound B. Okay, and then so all of these are going to be our different things that we can start with, our different givens. And this is going to should be like a roadmap to show us how to go from one thing to the other. So this will be grams, okay, which is molar mass. Okay, then this one would be volume, which is 22.4 liters at standard temperature and pressure. All of these three are going to be Avogadro's number. Let's see, I know an easier way to do this. Let's do this way. Or not. Okay. No, never mind. It's not going to work. So 6.022 times 10 to the 23rd. And that can be ions. It can be atoms. And it's going to be the same number, so make sure you write in that number. Or it can be particles. Okay? All right, then we can go on this side and have the same 5 starting things. I can have grams, which would be molar mass. I can have volume, which would be 22.4 liters. I can have Avogadro's number, 6.022 times 10 to the 23rd. And that can be ions, atoms, or particles. And it's all the same number. It's all going to be Avogadro's number. It's hard to write with the mouse. Okay. And then here in the middle, we've got a balanced equation. Okay. So if I start with grams of A, if I start here, then I'm going to use my molar mass and I'm going to go to moles of A. And then I'm going to use my balanced chemical equation to go to moles of B. And then let's say I needed to find liters of B. Then I would use that to find my liters, my volume. So this would be step 1, step 2, step 3, and then lastly, step 4. Okay? So remember your balanced chemical equation. Let's put one up here. Let's put hydrogen plus oxygen goes to H2O. Okay, so we need to balance that by putting a 2 there and a 2 there. So if I start with let's say I start with liters of hydrogen. Let's say I start with 2 liters of hydrogen, and I want to determine how much water I'm going to make. Okay, so I need to know the grams of water. And that's what I'm looking for. And this is what I've been given. Okay, so again, I've identified what I was given. I was given a volume of water I was given a volume of hydrogen and asked to find grams of H2O. So volume of hydrogen is where I'll start. I'll go to moles of hydrogen, so that's going to be my step 1. So according to that, there are 22.4 liters of hydrogen in 1 mole. Okay, so my liters cancel out. And then I'm going to go from moles of hydrogen over to moles of water. That's going to be my step 2, using the balanced chemical equation. So the balanced chemical equation says that for every 2 moles of H2, I have 2 moles of H2O. Okay, and then my last step is going to be going to grams of water right here. So moles of water grams of H2O. And that's my molar mass. 1 mole is 18 grams. And then I just do the math involved with that. So 2 times 18 divided by 22.4 divided by 2. And that will give me my correct answer. Okay, so that's just kind of how you would use this flow chart to help you with stoichiometry. I'm hoping to have a couple other little study tools and aids to help you with this soon. Divided by 22.4 divided by 2. So that comes out to be 1.6 grams of H2O. Okay, so if I start with 2 liters of hydrogen, I'll make 1.6 grams of H2O, assuming I have all the oxygen that I need. Okay, all right, so again, that's just a diagram to show you how to use this little flow chart to help you set up your stoichiometry problems. Hope this helps. Let me know.